Okay, so for today, your homework assignment, ions and aqueous solutions. Section A, those are all dissociation reactions. Dissociate means to separate yourself. So what's going to happen is when you place an ionic compound in solution, it's going to break apart into its respective ions. So for example, the first one, we have KCl. The K and the Cl are going to separate. Okay. Now, next we need to look up their charges. K is from group 1, so it has a +1 charge. And chlorine's from group 17. Those have a -1 charge. We need to make sure it's balanced, which it is, and we're done. All right, next one. Here's where we encounter a polyatomic ion. So what's going to happen is if you look on the back of your periodic table, NH4 is a polyatomic ion. You can look up its formula and its charge and see that it has a +1 charge. Chlorine, as we already determined, has a -1 charge. So there we go, it's already balanced. All right, we'll skip down to, skip down to number 4. So number 4, what's going to happen again is be on the lookout for polyatomic ions. SO4 is a polyatomic ion. So let's go ahead and write that over here. We can look on our polyatomic ion chart and see that it has a 2 negative charge. K, we already did. If we remember, it has a +1 charge. And then the last step, we need to balance it. So we need to put a 2 in front of that. Okay. When you do these, for example, when you do BaI2, I is a diatomic only in its elemental form, not in its ionic form. So when you do that, it's going to dissociate into 2 I negatives. Okay, let's skip down next to the dissociation reactions here. The precipitation reaction. Okay, this would be 2 ionic compounds coming together to form a solid. Okay, so let's look at number 8. Basically, if you remember, ionic compounds are attracted by positive and negative. Positives have to cancel out negatives. So if we have one aluminum that's a 3+ charge, one hydroxide that's a -1 charge, we're going to need 3 of these hydroxides, right, for every one aluminum. So it's drop and swap. Okay. And then we want to make sure we balance it out. Okay. So again, 3 of these have a 1 negative charge for every 1 3+. Okay. All right, next one. Let's scroll down here. Write the balanced net ion equation. This is done. Okay, it's a double displacement reaction. We need to find out which one is the precipitate. The precipitate's easy to find because it's the one that says solid. We're going to go ahead and write its formula right below it. Okay, and then the left side of the B and IE, the balanced net ion equation, are the 2 ions that formed it. Ba2+ and OH negative. We need to make sure we balance it. We have 2 OH negatives, so there we go. So if you notice, the BNIE is really just a precipitation reaction. Okay? So precipitation reactions and BNIEs are identical. They're one and the same. All right, we'll skip down to here. All right, this first one's probably the most difficult. So we're going to write a complete balanced equation. So these are going to be a double displacement reaction. So what we need to do is we need to write a formula for sodium, sodium carbonate. Sodium we need to look up on our periodic table. It has a +1. Aderite, look on the back of your periodic table. So we'll find quickly that carbonate is CO3 2 negative. So what we need 2 NAs for every 1 carbonate. So Na2CO3 is the formula of our first one. We're going to put aqueous there. Plus iron chloride. The 3, Roman numeral 3, means it has a 3+. Chloride is chlorine. So in group 17, it has a 1 negative. So if we drop and swap, we'll see our formula, FeCl3. Okay. And then form iron carbonate. So again, we need to look up our charges and drop and swap. So what we're going to need is we're going to actually need 2 irons, and we're going to need 3 carbonates. Okay, that'll cancel the charges out. And then our last one, sodium chloride. Sodium's a +1, chlorine's a -1, and that's AQ as well. Okay, then we need to balance it, put a 2 in front of there because we have 2 sodiums. Let's treat the carbonate, the CO3, as 1 ion. So we're going to need to put a 3 in front of that. Okay. Now that just messed up our sodiums. Well, that's okay. We can go ahead and fix them. We're going to put a 6 there now. Okay. Iron, we have 2 irons. And now that means we have 6 chlorines on the left, 6 chlorines on the right. We're done. All right, now what we need to do is find out. We need to write our B&A. It's just a precipitation reaction, but we don't know which of these two, the iron carbonate or the sodium chloride, is the solid. Well, that's what we're going to do up here with our general solubility guidelines. So, iron carbonate. Let's start with sodium chloride just to see. Sodium chloride says most sodium compounds are soluble, and it reiterates most chlorides are also soluble. So guess what? NaCl is our aqueous. That's why we put aqueous there. Iron carbonate. Well, let's look at the carbonate one. Most carbonates are insoluble. Insoluble means that's the one that forms our solid or our precipitate. It doesn't dissolve in water. There's our solid. Let's go and write the BNIE. Again, write its formula for the solid. Okay, that's what goes on the right side. What goes on the left are the two ions that formed it. We form from an Fe3+, and we form from a CO3 2-. And then we need to make sure we balance it. Okay, so hopefully that will help you in doing the this homework assignment.